All right, we got week 14, set 2, SWYK number 1, getting into more of the synthetic division. I got a lot of these practice problems, and you can sort through the details and look at what's going on in each one of these. I know this is a little bit redundant, but some of these problems look like they're set up differently, so that's why I wanted to show them to you and have you work on them. So x minus 7 produces a 7 for your synthetic division. You've got your 1, 4, negative 6, 5 across the top, and you can go through. Always make sure you drop down that first entry. Some kids don't do that, and then they end up screwing up the whole thing. Okay, and then you just do the multiply, add, multiply, add, multiply, add. You ended up with a really big remainder, much bigger than the other ones have been. Of course, we know that we'd write our remainders 502 over x minus 7. And then we've got our constant at 71, our linear at 11, and our quadratic at 1. So that's where this comes from, x squared plus 11x plus 71. The one thing I wanted to emphasize with this and continue to emphasize is that when something has a remainder of 0, we call it a factor. When it's not equal to 0, it's not a factor. So what we say here is x minus 7, not a factor. Okay? They didn't ask me that, but you need to know so that as we get farther and farther ahead, that'll make sense to you. Has to be a remainder of 0 to be a factor. Question 2, more synthetic division. So here we have x plus 5, which produces negative 5 for my 0, right? Carry down the 1. Oh, and we have to look at this and go, okay, there's no missing terms, right? 1, 7, 2, negative 40. And then just multiply, add, multiply, add, multiply, add. Ding, 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 ding. Whoa, look there, we got a remainder of 0. What does that mean? X plus 5 is a factor. Okay. Well, we kind of already knew that. You know why we knew that? Because look at their answer blank. X plus 5. They were kind of giving you a hint on that one. Anyway, what did we find when we got done with our synthetic division? We got x squared plus 2x minus 8. That can be factored further into x plus 4 and x minus 2, which is exactly what we needed to do to finish that question. We just took the quadratic and factored it further. Moving on down the road. Next, we're talking about what's called the remainder theorem. The remainder theorem says that you can take a number and plug it in. Let me zoom in on this. So in this particular remainder theorem question, number 3 here, they're telling me to plug in the number 3, okay, which we show you how to do. This 3 would go with x minus 3. Suppose I was doing synthetic division, and I took this big thing and I divided by x minus 3. You can get the remainder using the remainder theorem by taking the 0 that comes from the factor and plugging it into the numerator, so to speak. So that would be 3 cubed plus 2 times 3 squared minus 7 times 3 plus 3. And when I did all that out, I got 27. What does that tell me? That tells me that x minus 3 is not a factor, right? Because we didn't get 0. I know they didn't ask me about the whole factors, x minus 3 is not a factor or is a factor, but I need to know that. So, better get used to it. Question 4. Your favorite, fractions. They want me to plug in 1/2. Ooh, so plugging in 1/2 to all of those. So I did that. 1/2 to the 3rd power, 1/2 times 1/2 times 1/2 is 1/8. Okay? And then 1/2 squared is 1/4. So we have 2 times an eighth. Hey, that's a quarter. Minus a quarter. Okay, well, so those are going to cancel each other out. And then on the end, I had 4 times a half plus 1, which is 2 plus 1, or 3. That way, I got a 3. What does that mean? And I didn't write it down. Now, that's an interesting one. Hold on. I know you'd be tempted to say that x minus 1/2 is the factor that goes with 1/2. But in a lot of cases, we don't deal with fractions like that. Now, it's true that 1/2 would be the 0 that comes from x minus 1/2. But a lot of times we we multiply by 2 to get integers, and so what we would end up getting is 2x minus 1 equals 0. So we could say in this case, because we got a remainder of 3, that 2x minus 1 is not a factor. And the reason I know that we're dealing with 2x minus 1 and not x minus a half is because there are no fractions for coefficients. All of these are nice whole numbers, no fractions. Okay, moving on to question 5. We get into something different here, right? X to the 5th minus 1 divided by x minus 1. All right, x to the 5th minus 1. Well, that means that we have missing terms, right? There's no x to the 4th, there's no x to the 3rd, there's no x to the 2nd, there's no x to the 1st. So what I had to do is I had to put a 1 for x to the 5th, 0 for x to the 4th, 0 for x cubed, 0 for x squared, 0 for x, and then a minus 1 at the very end. If I don't do that, I'm going to get the wrong answer. So, carry down the 1 like we always do, right? Multiply, right? That gave me 1. Add gave me 1. Multiply, boo, a lot of multiplying and adding and multiplying and adding and multiplying and adding. And I got a 0 at the end. That's my remainder, right? What does that mean? Means that x minus 1 is a factor. That's right. That's what that means. X minus 1 is a factor. So we ended up with x to the 4th plus x cubed plus x squared plus x plus 1 with a remainder of 0. The last one also has the missing terms, right? There's no x cubed terms and there's no linear x term. So on my top row I had 1, 0, negative 6, 0, and a negative 31. Okay? Probably better get rid of those lines because they probably make people think of division. I'm not dividing, seriously. Okay. So we carry down the 1 like we always do, and then we multiply and add and multiply and add and multiply and add till we get down to negative 39 at the end. Of course, in pre-calc we'll write it as negative 39 over x plus 2, but they want the just plain old negative 39. X plus 2 is definitely not a factor. It did not go in evenly. I think that's it for this particular one. It is. Have a wonderful SWYK.